Welcome. Today we're exploring Chroma, an open-source vector database that brings semantic search superpowers to AI applications. Let's see how it works. Chroma turns unstructured data like text, images, or code into searchable memories for AI. You add documents, Chroma computes numerical fingerprints called embeddings, and then you can search by meaning, not just keywords. Imagine a library where every book has a GPS coordinate on a map. Similar books cluster together geographically. When you ask for books like a mystery novel, the librarian finds the 10 nearest coordinates. That's vector search. Embeddings are coordinates, and Chroma's indexes make neighbor lookup blazing fast. Under the hood, Chroma blends Python and Rust. Python gives you a friendly client SDK and fast API server. Rust delivers the performance-critical storage engine with HNSW vector indexes, Tantivy for full text search, and Arrow for efficient columnar storage. It's the best of both worlds: prototype in Python, scale with Rust. Here's how the pieces fit together. Client SDKs connect via HTTP to either the Python Fast API server or the Rust-Aksum frontend. For local embedded mode, Python can call Rust bindings directly, zero network hops. All paths lead to the same storage layer. SYSDB manages metadata, segments hold your records, and HNSW indexes power vector search. Let's trace a write. Your app calls collection.add with documents. The client sends them to the API server, which appends records to a write-ahead log and immediately acknowledges. In the background, a compactor reads batches from the log, builds HNSW indexes, and flushes immutable segments. This design keeps writes fast and queries consistent. Hybrid search is where Chroma really shines. You submit a query like password reset not working with metadata filters. First, HNSW finds 1,000 semantically similar docs. Second, Tantivy matches keywords. Third, metadata filters narrow the pool. Finally, reciprocal rank fusion merges the rankings. Docs that score high on both vector and keyword relevance bubble to the top. You get the best of semantic understanding and precise keyword matching. Chroma adapts to your needs. Start embedded for local prototyping. Python calls Rust directly with zero network hops. Deploy the Python Fast API server for internal teams who want multi-tenancy. Scale to production with the Rust-Aksum frontend backed by distributed workers and object storage. Same API, 3 deployment modes. Let's check the community heartbeat. The repo is active. Last commit was just yesterday. We're seeing steady development with recent activity from Dave Dash. With 2 branches and ongoing commits, this is a living, breathing project that's actively maintained and growing. So what can you build with Chroma? Semantic search over docs and support tickets. RAG systems that feed relevant context to language models. Recommendation engines powered by behavior embeddings. Image search by visual similarity. Code search that understands what you're trying to do, not just matching keywords. If your app needs to understand meaning and find similar things, Chroma has you covered. That's Chroma, an open-source vector database that lets you search by meaning, not just keywords. Whether you're prototyping locally or running at production scale, it combines the ease of Python with the speed of Rust to make semantic search feel like magic. Thanks for exploring with me.